morning everyone. I am Priyanka Rajput. In today's session, we will discuss about the cycloconverter. In previous lecture, we have already discussed the definition of cycloconverter, its type of cycloconverter. Today, learn about the principle of step-up cycloconverter as well as we will see about its working. So, before we start, firstly, what is a cycloconverter? Cycloconverter is converter which converts AC signal into the AC signal. In a cycloconverter, convert AC signal into AC signal, but at a one frequency to different frequency. Means it convert frequency. It's convert fixed frequency into the variable frequency. The basic definition of cycloconverter. We have already discussed about the step up and step down cycloconverter. If we will talk about the step up cycloconverter, means what? Step up means what? Whenever output frequency is greater than as compared to its supply frequency. So it is called step up cycloconverter. Now, if we will talk about the step down cycloconverter, means what? Whenever output frequency is less than its supply frequency, so it is called step down cycloconverter. Okay. Now let me start principle of step up cycloconverter. Here we will see we are seeing the working of cycloconverter, step up cycloconverter. Now see the basic diagram of cycloconverter, step up cycloconverter. You can see here we are using a 4 thyristor P1, P2 and P1, P2. Thyristor P1 and P2 for positive thyristor. Okay, and thyristor N1 and N2 for the negative group thyristor. Okay, so basic of this diagram, it's have a 4 thyristor P1 and P2 for the positive group thyristor and N1 and N2 for the negative group thyristor. Okay. Step up cycloconverter. Here we are covering the topic of step up midpoint cycloconverter. Okay. Why it is called a midpoint cycloconverter? Because here transformer, it's a primary side and this is a secondary side. Here we are connecting the load terminal with the secondary midpoint. This is the secondary winding. We are connecting the midpoint at a midpoint of secondary winding of transformer load. Load are connected with the midpoint of secondary winding of transformer. That's why it's called a midpoint step up cycloconverter. Clear? 4 thyristor connecting the load. Now let me start its working. Firstly, thyristor P1, P2, P1, N1, P2, and N1, N2. Firstly, we start the triggering of thyristor. Firstly, we start the thyristor from the P1. Means at the first time we will trigger the thyristor P1, positive group thyristor P1. At omega t is equal to, we start the P1. That time our terminal A is positive with respect to B. Okay, means A is positive and B is negative. So means this negative and this one is a positive. Now, this is a positive, means thyristor P1 is a forward bias, thyristor N2 is a reverse bias. For this, thyristor P2 is a also forward bias and thyristor N1 is a reverse bias. So now, firstly, we trigger thyristor P1. So our current flow with the follow of this path. Okay, we take the different direction of current RPS and voltage is this. Means what? Our flowing of current in the same direction of reference direction. It's a load current. So we get the output voltage of the cycloconverter in the positive side. Means you can see here the waveform. This is the supply voltage for the positive envelope and this is the supply voltage for the negative envelope. Firstly, we trigger the thyristor P1. So, thyristor P1 get triggered for this duration, for this interval. After that duration means After that duration, we will trigger the thyristor of N2. Okay. Now, this N2 is triggered means polarity get changed. Means this A point is now negative and B point is positive. This point is negative means this thyristor get natural commuting. Cause of this is a negative terminal, here is a positive terminal. Thyristor anode is connected with negative and cathode is connected with the positive. That's why this thyristor T1 get naturally commuted and thyristor naturally commuted. Now that time we will again now trigger thyristor N2. So this is positive, this is negative. So now our thyristor get low current from the load to supply. So this flow this path means that time our current is opposite with its reference direction. So that's why we get the output in the negative side. So at that time we trigger the thyristor N2 and we get the output voltage for its distribution. So here N2 is triggered. Here P1 is working. Okay. After that we repetition this same line. Now again trigger the thyristor P1. Now for this duration again get triggered the thyristor N2. Now again the thyristor P1 and again get triggered the thyristor N2. So here P1, P1, here N2 and N2. After that we get triggered. After this N2, we get trigger P2 thyristor or P2 thyristor. You can see here. Now terminal are changed means A is negative and B is gate positive. So cause of this positiveness, we trigger the thyristor P2. Now our current will flow the path from the path of P2 and load and this. At that time, our load current is similar, its reference direction, so we get the output voltage in the positive. At the same time, same this time, we get trigger the thyristor N1, N1, okay. When N1 is triggered, that time our load is current is flow from this direction, means current is in opposite direction with the different direction. So that's why we get the waveform with the help of N1 thyristor is in a negative direction. Now this N1 is again triggered to thyristor P2. This P2 is again triggered to N1. This N1 is again triggered to P2. Then this cycle is repeated. So we get this type of waveform P2, then P2, then N1, and here is N1. So you can see here. Here, this is a one cycle, but we get output cycle is lot of number as compared to large number of cycles in the output waveform. You can see one cycle, second cycle, three cycles. 4 cycle, 5 cycle, and 6 cycle. So that's why it is called step up cycloconverter, because its output frequency is greater than its supply frequency. So it is a waveform of the step up midpoint cycloconverter, and this is a basic diagram of step up midpoint cycloconverter. So conclusion is that in a cycloconverter, step up cycloconverter, we are connecting total number of 4 thyristor, P1 and P2, N1 and N2. P1 and P2 is a positive group thyristor and N1 and N2 is a negative group thyristor. At a one time, we triggered P1 and N2. In a second time, we will trigger the pair of thyristor P2 and N1. So then after we complete this waveform. Okay, thank you everyone. In the next session, we will discuss about the bridge type step up cycloconverter. Thank you everyone.